6.9 is integration using substitution. We're going to start it today and then we'll finish the rest tomorrow. Okay, we often call this use substitution actually. If you have a composite function, when we take the derivative, we use the chain rule. If you're trying to take the antiderivative of something that involved the chain rule, we do what we call use substitution. So the first one, you're kind of going to see the process. Eventually, you'll do the first type of problem in your head, and then you'll just so we can get the hang of it today, and then we'll practice a little bit. Okay, so I would like to find the definite integral of this. We don't have like any kind of product rule in antiderivatives, and I don't actually want to multiply this out 5 times. So I do know the antiderivative of something to the fifth, and I know the antiderivative of 3x minus 4, but that's not helping me right now. Okay, so I look for a composite function. This is the quantity 3x minus 4 to the fifth, so I believe the inner function is 3x minus 4, and then that is being raised to the fifth. Okay, so on the side, I'm going to pick u to be 3x minus 4. My goal is to rewrite this antiderivative in terms of u. Okay, so I'm going to go ahead and take the derivative of this function. The derivative of u is du. It's actually du over dx is what we learned, but I'm going to erase that in a second. The derivative of 3x minus 4 is just 3. Now, we have not separated the du and the dx before, but you can separate them. They're like separate quantities. So I'm going to multiply the dx to the right side because it's convenient and because I'm allowed to. My goal is to rewrite this expression using only u. So I'm going to go over here. This 3x minus 4, I can replace that with u, and we'll keep the fifth on it. Okay, but I still have this dx over here, which is a problem. So I'm going to go over here and solve for dx. Dx is going to be du divided by 3. Okay, so where dx is, I can change it to du and divided by 3. I'm going to rewrite this as 1/3 du because it's going to be easier. Okay, so instead of writing dx, I'm going to write 1/3 du. The du normally goes at the end, so I'm going to keep it at the end. The 1/3 could go here. I could put the 3 down here. I can put it outside the integral. I'm putting it outside here just because it's convenient to put it there and it doesn't change anything. Okay, now this integral is completely expressed in terms of u. So now I can just take the antiderivative like normal and my answer will have u in it. So I'm going to keep the 1/3 here. The antiderivative of u to the fifth is u to the sixth divided by 6. And then because I'm doing an antiderivative, I'm going to add a constant. Okay, and then this would be 1/18 u to the sixth plus c. But since my original problem was in terms of x, I'm going to go ahead and plug back in for u. Instead of u, I'm going to put 3x minus 4 to the sixth, and then I'm going to remember my constant at the end. If you want to check your answer, if you take the derivative of this and you use the chain rule, you should end up with this as your derivative. Okay, we're going to try 3 more today, now that you've kind of gotten the hang of it. Okay, so for b, I have the antiderivative of 6x squared times x cubed plus 4 to the fifth. Okay, this kind of looks like a chain rule and a product rule and all kinds of things, but in antiderivatives, we don't have a product rule. So it must be some kind of use substitution. Use substitution I'm looking for like an inner function or the inner function of a composite function. This is 6x squared. Okay, it's being times by the quantity x cubed plus 4 to the fifth. Since I'm taking x cubed plus 4 and I'm raising to the fifth, I believe x cubed plus 4 is my like inner function. So on the side, I'm going to let u equal x cubed plus 4. Okay, my goal is to rewrite the integral using only u. So I'm going to go ahead and take the derivative. Just writing du because it's convenient to leave the dx on the right side. The derivative of x cubed is 3x squared dx. And now I'm going to try to rewrite this integral. Okay, where the x cubed plus 4 is, I can make that u to the fifth. But I'm still stuck with this dx and this 6x squared. So I'm going to go over here and solve for dx. Okay, dx is du over 3x to the second. Well, that looks really bad. But left in my equation, I have to do dx times 6x to the second. This is dx. If I take the quantity represented by dx, which is du over 3x to the second, and I times it by the 6x squared, the x squareds cancel, and then I just have 6 over 3, which is 2. So where the 6x squared then du is, I can plug in 2 and du. Normally the du goes on the left side. Normally the 2 goes on the, wait, left? No, du is on the right. 2 is on the left. You can put it inside the integral or outside the integral. It doesn't make a difference. Now that this integral is written entirely in terms of u, we just take the antiderivative like normal. So I'm going to raise it to the 6th. I'm going to divide by 6. I'm going to add a constant. And then because my original function was written in terms of x, I'm going to resubstitute back in. 2 6 1/3 though, so let me simplify it too. Where u is, I'm going to re-plug in the x cubed plus 4. It's still to the 6th. It's still plus a constant. Okay. Okay, now I'm going to do d first because I think d is a little bit easier. That's the only reason. Okay, integral of sine of x times e to the cosine x. It looks like product rule. There's no product rule for antiderivatives. So I'm looking for a composite function. This is just sine x. This is e to the cosine x. So there's two functions there. There's e and there's cosine x. I'm doing e to the cosine x. So I believe cosine x is my u. If you make a mistake on picking your u, it just won't turn into it. You can't figure out. You'll have x's and u's all mixed up. It'll be a mess. Okay, let's try this though. Take the derivative of both sides. Du equals negative sine x dx. I go back. I'm trying to rewrite this in terms of u. The e is fine. Where the cosine x is, I'm going to write u. I still have a sine x here and I have a dx here. So I'm going to solve for dx. Dx is du divided by negative sine x. Okay, so I want to multiply what I got for dx, which is this, times sine x, and then I need to see what's left over. You don't have to show all these steps. You're going to do some of these in your head eventually. Okay, so this is dx. I need to times it by sine x. When I times it by sine x, the sine x's cancel. Your x's should always cancel. If you're stuck with x's, you've made a mistake or you picked the wrong u. Okay, after the sine x is canceled, I still have a negative left and I have a du. Du normally goes on the right. The negative could go on the left. It can go in the integral or out of the integral. It doesn't make a difference. Okay. Antiderivative of e to the u is e to the u. So this is negative e to the u plus a constant. And then I'm going to make sure I plug back in my u at the end. And then if I've done it right, it should actually work. This one's pretty easy to check. If I do the derivative of negative e to the cosine x, I get negative e to the cosine x. And then chain rule, I times by negative sine x, which is why I got this positive sine x, derivative of a constant 0. So it does work. Okay, one more today, and then we're going to practice tonight for our homework. Okay, this one looks a little, there's a lot going on here. I could distribute the top and I could divide it by root x and I would get the correct answer. So if that looks easy to you, you could go ahead and do that. Okay, what do I have? I have the square root of x minus 1. That quantity is squared, but then I'm also dividing by the square root of x. So you kind of have to guess which one's your u. Since this is being squared, I'm going to pick this as my u value. If I pick wrong, I will find out because when I try to do the dx situation, it will not cancel. Okay, let me take derivative. Derivative of this is this. X to the 1/2 is 1/2 x to the negative 1/2. So 1 over 2 root x dx. Let me go back. I'm going to write this in terms of u. That u I picked is being squared. There is also a root x at the bottom, but let me figure that out. Okay, so I am left with a square root x at the bottom and times dx. So I'm going to solve for dx. 2 root x du equals dx. Okay, the thing I'm left with is I have dx and then I have a root x at the bottom. This is my dx. If I put a root x at the bottom, What happens? The root x is canceled, which is what I always want to happen. And I'm left with the 2 and the du. Okay, du on the right, the 2 can go in the integral, out of the integral. Doesn't matter. Wherever looks easier for you. And now we do antiderivative. 2u to the third divided by 3 plus a constant. And then make sure you plug back in your u to the third. I'm going to make this 2/3. Okay, and then homework, you're going to go ahead and practice these. And then tomorrow we will do a couple trickier ones and then do a definite integral.